All right, can I show you like a sort of a super problem, meaning that there's a lot of stuff on the number line and just a few more plus and minus signs to think about. And then I'm going to try to give you one problem to wrap up with. But I do like to kind of do all this in one period because tomorrow we're going to just focus on some graphing ideas. So appreciate your attendance and also your effort just with continuing to focus here. This is kind of it. It's funny, we get here pretty quickly, but what we're doing today is like the main thing, that is using slope to help analyze a function. All right, I've got x to the fourth minus 4x cubed plus 3. And then we've got this negative 4 comma 3. The book likes to use this interval notation. So make sure when you see that you realize it's an interval. It's not a point. So they're endpoints. Okay, that'd be like the first thing that you would want to conclude. These are endpoints. And although I don't see most students doing this, because even myself, I tend to not do it, you actually could make your number line, or at least the beginnings of your number line. Now, the reason I am doing this, even though I confess I normally don't, is because I don't want to forget about these endpoints, and sometimes people do. So whatever it takes, don't forget about the endpoints. All right, let's do it together. But there's things in here that you guys could do, but we'll just do it together here. Nice little derivative. You do have some higher powers, though, and so that's really what makes this problem a little bit trickier. Okay, we have the derivative of 4x cubed minus 12x squared. Even though that's still just a polynomial, it's got some higher powers. But we'll set it equal to 0. And of course, when you set something equal to 0, you're finding the critical points. Now, be careful. You don't want to just divide out the extra x squared. You don't want to divide it out. You want to factor it out. Okay, because that x squared is going to be part of my solution set. I also factored out a 4. Darn it. We need to change something here. It's a simple change, but we need to change something. It's my fault. This was supposed to be an x squared. So the original equation was minus 4x squared. As I'm sure you can see, that's going to change the derivative. And it actually does change the factoring a little bit too. My fault. So we get a derivative of minus 8x. And now we're just going to factor out a 4x. That leaves us with an x squared minus 2. Okay, that one little exponent messed some things up. All right, so I factor out a 4x. I'm left with x squared minus 2. All right, this thing's equal to 0. Pretty good normal algebra stuff here. Make sure that you do solve carefully. You solve and get x equals 0. Not 4, but x equals 0. Now this one right here, make sure you see the square root. You're taking the square root of 2. It's going to give you plus or minus root 2. And I wanted to make sure that that was part of our answer, because I want to work with that with you guys. Are you kind of wrapping your fingers around what's going on here? These are critical points. That means that they are places where a slope could change. Now, I did say where the slope could change, because there will be some times where, even though it's a critical point and it shows up on our number line, that the slope actually continues to be positive or continues to be negative. I just want to throw that out there, that even though we haven't seen it yet, there's a possibility that things stay the same. But right now we have 1, 2, 3, 4 sort of regions, 4 intervals. Just by the way, we get to a problem like this, it would be on the calculator part of a test. You still would show your work, but when it comes to like thinking about some numbers to plug in, you could think about the decimal of square root of 2. It's actually 1.4, but that would give you comfort enough to say that -3 is in here. Again, this is equal to -1.4, so that gives me enough comfort to say that I have a -1, a 1, and I guess I'm going to have to choose the number 2 right here. Those yellow numbers, and I see this, that sometimes kids get confused. In other words, with the white numbers. But those yellow numbers are the ones I need to test. I need to plug them into the derivative. Okay, and again, you could be using a calculator at this point. It is important, though, that you would actually go through this when you're doing your assignment. That's how you learn. So even though I'm just going to tell you some things, make sure you're doing a little thinking with me. Let's go backwards. Let's plug in 2. That's kind of easy to do. You can plug in 2. You cube it. That gives you 8. Times 4 is 32. Minus 16. 32 minus 16. Okay, it actually comes out to be positive 16. Are you ready to just say positive? Plug in 1. 1 cubed, 4 times 1, minus 8. At least think about one of these. Maybe it's one of them that we already did. Just make sure that your eyes are focused on the derivative. You're plugging into 4x cubed minus 8x. Okay, we end up with a positive here. We end up with a negative here. That is, we end up with a negative slope, a positive slope. What do you guys think? Do you have any questions? Like I said, alternating between positive and negative is not necessarily a given. It is common, but it's not a given. So you'd have to find each of these so that we can then, with confidence, think about our graph. I'll tell you that I find that when kids start to be able to do this, then you're getting the idea. I'm talking about picturing a graph that has a negative slope and then a positive slope. Now, are you more of the type that you want to draw that? If I just show you, then I ruin it for you. But can you picture a graph that has these negative, positive slopes? Do you realize that these white numbers end up actually being the place where this changes? Like, you might want to make the white numbers points because, well, that's what they're going to be. Okay, my graph goes up until I get to 0. My graph goes down until I get to positive root 2. My graph goes up until I get to 3. There's a lot of numbers on the board, but it's understanding that the white numbers are actually the critical numbers. They're the maximums and minimums. The yellow numbers were just there to help us say positive and negative. Okay, that graph that I just drew, do you guys understand? That's the graph of the function. Like, that's big stuff. We just graphed f of x equals x to the fourth. And it kind of looks like a W. You're always going to get this like little box of answers. Organize it how you want. I just ask you to organize it. On a test or quiz, I'll give you a space and you actually fill it in the same way as everyone else. Okay, but it's almost too easy now to say -4 is a max, 0 is a max, 3 is a max, because the slope was positive and then switched to negative, or because the slope just began as negative. But if you think about the slopes, we would have to conclude that -4 is a max, 0, and 3. Now, I'm doing something just a little different here. I'm going to skip the y values. There are some problems where you get to do that because I'll say so. So I'm just going to skip the y values just to keep it a little simpler. But take a look at my minimums. My minimums are both of the root 2's. So I can write that as plus or minus root 2. And then do you realize that this increasing, decreasing is just another way to describe a positive and negative slope? Okay, so we had a positive slope from negative root 2 to 0. So negative root 2 is less than x is less than 0. And then we had a positive slope from positive root 2 over to 3. So I can write that as an inequality if I want. And then we've got some negative slopes for the other spaces. All right, so I've got -4 is less than x is less than negative root 2, and then 0 is less than x is less than root 2. As I kind of said to you guys yesterday, algebra class would have had something to say about this equation. It would have said it's to the 4th degree. And if I have 4th degree, then I end up with a graph that has this many turns. Okay, but calculus class says that if I have a 4th degree, then I'm going to get a certain derivative that has a certain critical points. And those critical points give me help me to create my slopes. And of course, the slopes actually give me the turns. It all kind of goes together. Let me give you one, and I want you to try to approach this like you're in calculus class. I want you to use our slope strategy. And nobody said it had to be like a big hard equation. It's x cubed plus 4. This is the kind of equation that it's interesting to see if you can adapt. Can you adapt? put 0 on the number line. What does the number line conclude? But put 0 on the number line. Now, if you're like, well, what's my conclusion? There's a lot of conclusions, like what's going on with the slope? What's that mean for all this max min stuff over here? Any of those conclusions are part of this answer. So you're trying to think, what kind of slope? And what does that mean for my max mins and such? Now, as long as you plugged in some number to the left of 0, I don't care what it was. I mean, it should have been something negative. And then something to the right of 0, again, as long as it's something positive, you should have concluded pretty quickly that no matter what you plugged in to 3x squared, you were always going to end up with something positive. Okay, it's going to be 3 times something positive. So it's always going to be positive. So what's going on here? First of all, what's going on with our graph? It's a graph that's going up. Good, it's going up. Wait, a graph that's always going up? What about at 0? Now, here's a little technicality, because at 0, you kind of discovered that that's when the slope is equal to 0. So to be a little more accurate, yes, the graph's always going up, except at 0. And what's happening at 0 is we have one moment where the slope is 0. And a graph where at one moment the slope is 0 has this place where it gets flat. But again, it's only flat for that point. So I can't really draw like a plateau. But what I actually drew, and again, you're in calculus class, so I want you to use calculus, but that doesn't mean you can't ignore or forget algebra, because what you actually just drew was an x cubed graph. And hopefully you remember that x cubed is going to look like that. It's going to always go up, except at that one place. Is x equals 0 a maximum or minimum? Well, the short answer is no. X equals 0 is just a place along the way. So was x equals 0 a critical point? Yes, it was a critical point, but it's not a max or min. What is it? You'll have to come back for the next lesson. Not tomorrow, but like the next section. So x equals 0 is a critical point, but it's not because the slope changes. Something else changes. Okay, it'll actually be the last idea that we'll talk about next week. Increasing. Honestly, I would give you credit if you said always, but to be a little more accurate, you should say always except when x equals 0. So negative infinity to infinity, comma, x not equal to 0 would be the best answer, or something that says not 0. I wanted you to see a problem like this. I wanted you to see a list of answers that appears to be pretty empty. It's okay. There's no max or min. It's always increasing. It's never decreasing. And the slope says so. What are we going to do? Graph the derivative. Do I even need a calculator to graph the derivative? How do you graph the derivative? What's the graph of 3x squared? Good. It's a parabola. Now, it's a parabola, but the most significant thing about the parabola is it's always blank. It's always, you got to kind of be careful how you say it. It's always in a positive place. What I mean by that would be the y values. Now, maybe you shouldn't be surprised. And maybe you're kind of like, yeah, I'm getting it. But look, the y values are positive. Look, the y values are still positive. Now, there is one place where they're not positive. It's x equals 0. But that's the place where the slope was supposed to be 0. Okay? But this is good stuff. This is the derivative. It's a parabola. This is the original function. It's a cubic. But the slope says so. And again, the slope means the values that you see here. The values say so. I know for some of you, again, it takes you back to physics. But it's neat to see the calculus, sort of the theory connection here. All right. Good day. Good day. Again, most of the concepts are wrapped up in this lesson.